Hi, my name is Dr. Gregory Kowalczyk, also known as Dr. K, and thank you for your interest in my chemistry course. I am a retired university professor, having taught there for over 20 years, and I bring all of my experience from those 20 years here into this class. Before we go any further, I do want to emphasize that this is the second semester general chemistry course. I do have a first semester general chemistry course posted on Udemy, and maybe you are familiar with that already. Regardless, the format of this course will be exactly the same as that for my first semester general chemistry course. I will be following the OpenStax chemistry book, and that is a free textbook available to you for download in PDF form, and I will have that textbook available for you in the first resource folder for the first lecture. Everything covered in this course is exactly what is covered in any second semester general chemistry course at any university or college in the country. I will be covering the same topics that I did when I taught it in the lecture hall. So you're getting the entire general chemistry course for a fraction of the tuition money that you would spend. And you may very well have to take that course at the university. And here now you have an opportunity to get the inside scoop on the material that's going to be covered. So ideally, this course that I have here is ideal for students who have never taken general chemistry before, and now at the university level they have to take it. Or students who have taken chemistry many years ago and may need a refresher. Regardless, if you're in that situation where you need to take General Chemistry 1 or General Chemistry 2, this course for General Chemistry 2, and my Udemy course for General Chemistry 1 available as well. Regardless, let's go ahead and look at all the topics that are going to be covered in this course. So our first section then will be liquids and solids, where we're going to start with intermolecular forces, followed by properties of liquids, phase transitions, vapor pressure and boiling points of liquids, followed by determination of heat of vaporization. Then we'll look at heating and cooling curves, phase diagrams, and our last topic in this chapter will be crystal structure of solids. Moving on to the next chapter, solution chemistry, the dissolution process. We'll define solutions and look at solubility again. We're going to look at solutions of gases and liquids and look at Henry's law. Concentration units will be introduced, and also we'll be looking at how to convert from one concentration unit to another. And then we have 4 colligative properties that we're going to deal with in the back part of this chapter. Moving on to section 3, kinetics, chemical reaction rates and factors that affect them. Determining the rate law for a chemical reaction, and then we'll look at the reaction order and rate constant units. The integrated rate laws for the 0th, 1st, and 2nd order reactions will be introduced. Then we'll talk about half-lives of reactants, collision theory and activation energy, followed by reaction mechanisms, and also catalysis. Then moving on to equilibrium chemistry, the main part of second semester general chemistry, we're going to introduce the idea of chemical equilibria, the introduction of equilibrium constants and the reaction quotient. We're going to look at both homogeneous and heterogeneous equilibria and distinguish between the two and why that's important. Le Chatelier's principle will be introduced and see how a chemical system will reestablish equilibrium if a stress is applied to that system. We're going to learn how to calculate the equilibrium constant K given the equilibrium concentrations, and then the reverse calculation. We're going to calculate the equilibrium concentration of reactants and products given the numerical value for the constant K. Chapter 5 is going to introduce our acid-base equilibria. We're going to define Bronsted-Lowry acids and bases. pH and pOH will be defined. Ionization of weak acids and weak bases, and the determination of the Ka and Kb values, the equilibrium constants for weak acids and weak bases. We'll then learn how to calculate the pH of both strong and weak acids and basic solutions. Hydrolysis of salt solutions. We'll be calculating the pH of those as well. We'll look at polyprotic acids, followed by buffer solutions, and finish this section with acid-base titrations. Moving on to our next section, equilibria of other reaction classes. Here we're dealing primarily with precipitation reactions from last semester. So we'll look first at precipitation and dissolution processes, followed by the solubility product, and that is our equilibrium constant for slightly soluble salts given the value of K sub P. We're going to determine those K sub P values from solubilities, and then do the reverse calculation using K sub P to calculate the molar solubilities of a slightly soluble salt. And then we're going to learn how to predict whether precipitation will occur or not. the common eye effect, which will affect the solubility of these salts, and the last topic will be Lewis acids and bases. Section 7, we're going to get back to thermodynamics. We're going to talk about spontaneous processes, followed by the introduction of a new thermodynamic property called entropy. We'll define the second and third laws of thermodynamics and see how that applies to our discussion of chemical reactions. And then we'll introduce Gibbs free energy. We're going to learn how to calculate Gibbs free energy, delta G0, from enthalpy and entropy values, and then how to calculate Gibbs free energy from the Gibbs free energy of formation, delta G0 sub F. We're then going to relate free energy with equilibrium and the equilibrium constant and delta G. Our last section is going to be electrochemistry. We're going to look at the galvanic cell, standard cell notation, followed by standard reduction potentials for half reactions and redox reactions that make up galvanic cells. We're then going to look at cell reactions in terms of the cell potential E0 and Gibbs free energy. We're going to look at the Nernst equation, which allows us to calculate EMF values at non-standard conditions. We'll talk a little bit about batteries and fuel cells, corrosion, and our last topic will be electrolysis. So now all you have to do is sign up for this course and start learning all the topics of second semester general chemistry.